Dear students, in this class we are going to be discussing about the oxidation of alcohols. There is oxidation of alcohols. When it comes to this, is one of the method used to distinguish between the primary alcohols, secondary alcohols, and tertiary alcohols. Now we are going to be discussing about the oxidation of alcohols. That is one by one we are going to be studying now. In this oxidation of alcohols, this the method is used to distinguish between the primary alcohols, secondary alcohols, and tertiary alcohols. How we are going to be distinguish these three types of alcohols? We'll see in this now. The first thing, the primary alcohol. That is primary alcohol is going to be treated with it's going to be oxidizes in the presence of an oxidizing agent, that is acidified potassium dichromate, that is K2Cr2O7. Otherwise, the presence of acidified K-4 potassium permanganate. It's going to be used at corresponding aldehydes. This on further oxidation is going to be used the carboxylic acid. It's going to be used the carboxylic acid. That carboxylic acid contains the same number of carbon atoms as in the alcohol. That about the primary alcohol. The first one we are going to be studying that. That is primary alcohol or CH2OH. This is about the representation of the primary alcohol. This alcohol is going to be oxidized. This is going to be oxidized in the presence of, that is acidified, that is KMNO4, acidified potassium permanganate. We are going to be get that respective aldehyde. We are going to be get that it forms an aldehyde. This on further oxidation, this undergoes the further oxidation, it's going to be used that corresponding carboxylic acid. That is about the carboxylic acid. Means in this you can observe that how many number of carbon atoms present in the alcohol. It contains the same number of carbon atoms in the carboxylic acid. This is about the primary alcohols, the oxidation of the primary alcohols. That is, the primary alcohols oxidizes in the presence of acidified potassium permanganate or acidified, that is potassium dichromate. It's going to be used the aldehydes. This on further oxidation is going to be used the carboxylic acid. That carboxylic acid containing the same number of, that is the carbon atoms. We'll take example for this. If you are going to be taken the example, that is example if you are going to be taken that CH3 CH2OH. Name of this compound is, that is ethanol, OL, that is ethanol. This undergoes the oxidation in the presence of KMNO4, that is acidified KMNO4. We are going to be get that is CH3, that is CH2. That the name of this compound is ethanol, A. Means the difference is OL means alcohol. Here AN means aldehyde. This is about the aldehyde. Now this on oxidation again. This further oxidation, we are going to be get that the carboxylic acid CH3COOH. The name of this is ethanoic acid. The name of this compound is ethanoic acid. The name of this compound is ethanol. This is about the primary alcohols. Then the next comes to that the second one, that is the secondary alcohols. Secondary alcohols generally we are going to be represent are C, H, OH, R. This is about the secondary alcohol. This undergoes the oxidation. Means in the presence of this acidified, that is KMNO4. This is acidified KMNO4 solution. we are going to be get that is the respective folding. We are going to be get that respective ketone. We are going to be get that is in this we are getting the product here already, but in this we are going to be get that ketone. This we are going to be get that ketone. This further oxidation. This undergoes the further oxidation. We are going to be get that. We are going to be get that the carboxylic acid. That is the difference is this is a secondary alcohol. Then this about the ketone. Then this about the carboxylic acid. You can find that, means you can observe that, means which contains the, in this first case it contains the same number of carbon atoms. That is carboxylic acid forms which contains the same number of carbon atoms in the alcohol. But in the second case it does not contain the less number, means the formed carboxylic acid contains the less number of carbon atoms when compared to the that is reacted in the secondary alcohol. We will take example. We will read. It is that is CH3, CH3, OH. This is isopropyl alcohol. We are going to say that isopropyl alcohol. Otherwise, we can the IUPAC name is propane to all. It is propane to all. The IUPAC name of this. This undergoes the oxidation. That is, this undergoes the oxidation in the presence of acidified K-membrane solution. Then we are going to be get that acetone. That is, we are going to be get that acetone. Then the IUPAC name is the IUPAC name of this compound is propanol. That is the common name is acetone. This on further oxidation. This on further oxidation. We are going to be get that. We are going to be get that. That is the carboxylic acid CH3COOH plus CO2 plus H2O. Means this is a product obtained in this case which contains the less number of carbon atoms. Which contains the less number of carbon atoms. Means in the first case it contains the 1, 2, 3 carbon atoms. In the reactant it contains the 3 number of carbon atoms. But in this contains the only 2 number of that is 2 number of carbon atoms. Means in this contains the same number of carbon atoms. But in this case the carbon atoms is going to be reduced. The carbon atoms is going to be reduced. That means this from this we can differentiate the primary alcohol from the secondary alcohol. Then next we are going to be discussing about the tertiary. That is a tertiary alcohol. We are going to get that tertiary alcohol. Tertiary butyl alcohol. The name of this compound is tertiary butyl alcohol. Butyl alcohol. This does not undergoes oxidation in the presence of this acidified KMnO4 and acidified potassium permanganate. But this undergoes that is dehydration, and that is dehydration. It undergoes the dehydration. Means it is going to be formed an alkene. That is going to be formed an alkene. That is CH3, C11, CH2, CH3. This undergoes the first undergoes that is dehydrated. At that time, it is going to be formed an alkene. Generally, we are going to be say that alkene. The name of this particular product we are going to be written as that is 2-methyl propene. 2-methyl propene. Then in this, we are going to be say that the next this further undergoes the oxidation. This alkene undergoes the oxidation. It is going to be formed. That is CH3 C double one O then CH. That is going to be formed that acetone. That is otherwise the IUPAC name is propanol. Acetone is going to be formed. This on again further undergoes the oxidation. It is going to be formed that is CH3COOH plus that is CO2 plus H2O. Means this about the tertiary alcohols. Means from this reaction and oxidation of this alcohols, based on this method we can differentiate the primary, secondary and tertiary alcohols. The primary alcohols undergoes the oxidation in the presence of that is acidified KMnO4 solution. Then it gives the aldehydes. This further oxidation gives the carboxylic acid. This carboxylic acid contains the less number of carbon atoms. In the secondary alcohols undergoes the oxidation in the presence of that is acidified KMnO4 solution. It's going to be formed the respective ketone is going to be formed. This further oxidation is going to be used the carboxylic acid, which contains the less number of carbon atoms when compared to the reactant. In the third tertiary alcohols, it does not undergoes the oxidation with the that is acidified KMnO4 or potassium permanganate. It is going to be potassium hydrochloride or potassium permanganate. This is going to be tertiary alcohol undergoes the dehydrate. It is going to be form alkene. This alkene undergoes the oxidation. It is going to be used the ketone. And further oxidation is going to be used the carboxylic acid. This is a method which is used to differentiate the three types of these alcohols. This is one of the important reactions. So many times asked in the examination. That is the catalytic dehydrogenation of alcohols. That is the catalytic dehydrogenation of alcohols. This is also be used to distinguish the primary, secondary and tertiary alcohols. How we are going to be distinguished will be checked out. The first, it is going to be used, that is the primary alcohol. The first we are going to discussing is the primary alcohol. This primary alcohol vapors are passed through red hot copper at 573 Kelvin. It's going to be formed that aldehyde. Here the reaction we can be written as generally the primary alcohol we are going to represent by RCH2OH. These vapors of this primary alcohol, that is the primary alcohol, is going to be passed through the copper, red hot copper, that is at 573 Kelvin. At the 573 Kelvin, at that time it is going to be formed that aldehyde. It undergoes the dehydrogenate. It forms the aldehyde. Means that is the dehydrogenation. Means removal of hydrogen. This is about the aldehyde. We are getting the aldehyde. Means this example for this we can be discuss. There is the CH3 CH2OH. The name of this compound is ethanol. Oil. These vapors of ethanol pass through the copper at 573 Kelvin. We are going to be get that ethanol, that is CH3CHO. That is it undergoes the dehydrogenate. It's going to be formed that ethanol, ethanol, OL. This is about the A. This is about the alcohol. Then with the dehydrogenation. That is the about the primary alcohol. Then vapors of secondary alcohols. That is vapors of secondary alcohols is going to be passed through the red hot copper at 573 Kelvin. It undergoes dehydrogenated. It's going to be formed the ketone. It's going to be formed the ketone. That we are going to be generally the secondary alcohol. We are going to be represent. That is secondary alcohol. That is the secondary alcohol. Secondary alcohol which is passed through the red hot copper at 573 Kelvin. 573 Kelvin. We are going to be get that ketone. We are going to be get that ketone. It undergoes dehydrogenate and is going to be formed that ketone. The outside product is ketone. Means example we can take for this. That is CH3, CH3. That is the OH. That is propane to all. That is the propane to all. That is these vapors of propanol. 2-propanol is going to be passed through the copper at 573 Kelvin. We are going to get the acetone. It undergoes the dehydrogenation. Then it is going to be formed. That is the propanol. That we are going to get the propanol or acetone. A common name is acetone. IUPAC name is propanol. Then I will discuss the tertiary alcohols. The tertiary alcohols does not undergoes the dehydrogenate because vapors of tertiary alcohol which is passed through the copper, red hot copper at 573 Kelvin does not undergoes the dehydrogenation because absence of the alpha hydrogen. Due to this does not undergoes the dehydrogenation. Instead of this, dehydrate is going to be dehydrated. It is going to be formed an alkene. It is going to be formed an alkene. We will see that. The tertiary alcohol can be done like this: R dash, R double dash, OH. This alpha carbon, does not contain the hydrogen. Therefore, which is passed through the copper, red hot copper, at the 573 Kelvin, this does not undergoes the dehydrogen. Instead of that, it undergoes the dehydrated. It is going to be, it undergoes the dehydrator. Means it is going to be formed an alkene. This particularly we are going to be taken for this. An example we are going to be taken. That is, instead of this R, we are going to be taken that CH3, then CH3. Example we are going to be taken. In this example, we are going to be written as CH3, C double bond, CH2, CH3. This about the alkene. This undergoes the dehydrate, means removal of water. Means here in this case it is going to be vapors of primary alcohol which is passed through red hot copper. We are going to be get an aldehyde. In the secondary alcohol, vapors of secondary alcohol which is passed through the copper at 573 Kelvin, we are going to be get the ketone. It undergoes the dehydrogenation. But the tertiary alcohols which is passed through copper at 573 Kelvin does not undergo dehydrogenation. Instead of dehydration, it undergoes the dehydrate, means removal of water. It is going to be formed. Why it undergoes the dehydrate instead of dehydrogenation? Because the absence of the alpha hydrogen. It is the alpha carbon. It does not contain any hydrogen. Therefore, absence of the alpha hydrogen, it undergoes this undergoes the dehydrator. The next we are going to be discussing the another reagent which is used to distinguish the primary and secondary and tertiary alcohols. The first we are going to be discussing about the now we are going to be discussing about the Lucas reagent. Lucas reagent. This this Lucas reagent which is used, that is Lucas reagent which is used to distinguish the primary alcohol, secondary alcohol and tertiary alcohol. There is first, what is meant by Lucas reagent? Lucas reagent means that is a mixture of, that is anhydrous zinc chloride and the concentrated HCl. We call it as a Lucas reagent. That we call it as a Lucas reagent. Lucas reagent means that is anhydrous zinc chloride, ZnCl2 less concentrated HCl. Hydrochloric acid is called as a Lucas reagent. This is also important for the exam. So many times asked in the examination. How it's going to be distinguished with the primary alcohol, tertiary alcohols and tertiary alcohols, primary alcohol and secondary alcohols means the first is going to be suppose the primary alcohol is going to be treated with the Lucas reagent, that is Lucas reagent. At that time, it does not get the turbidity at room temperature. No turbidity at room temperature. Only on heating it gets turbidity. This is about the primary alcohol. If suppose secondary alcohol, that is the secondary alcohol is treated with the Lucas reagent, it's gives the turbidity after 5 minutes. This is about the secondary. If you are going to be taken the tertiary alcohol is going to be treated with the Lucas reagent. It's immediate turbidity. Means this Lucas reagent means this is the mixture of anhydrous zinc chloride and the concentrated HCl is called as a Lucas reagent. This Lucas reagent is used to distinguish the primary alcohol, secondary alcohol and tertiary alcohol. That is the primary alcohol it does not give the turbidity at room temperature, only it gives the turbidity on heating them. But the secondary alcohols it gives the turbidity but after 5 minutes. Then the tertiary alcohols is treated with the Lucas reagent. We are going to be get the turbidity, immediate turbidity we are going to be getting. This is the method which is used to distinguish the, that is the primary, secondary and tertiary alcohols.